today's class. Today we're gonna talk about Java RMI. It's a little old solution, but still works, and you might encounter it in a corporate environment or in so-called enterprise applications, enterprise systems. So you might want to know what this is about, and it's fairly simple from a user perspective. So I think this will be a quick one. Right. So let's start with setting up the environment. So first of all, we are gonna use Maven, and we need an additional build plugin for RMI. It's an RMI compiler Maven plugin. That's because RMI generates a skeleton and a stub for each object, and these skeletons and stubs are well, they're generated by RMIC. And a skeleton is something on the server side and a stub is on the client side. It's similar as in gRPC. Now we're gonna create some classes so that we can actually do something. Let's synchronize the Maven project and create a package. Let's call it PL and here we're gonna create a class, well, an interface first, and this interface we're gonna call it adder. So it will start with, in the beginning it will mostly care about adding. So we're gonna create a function, and this will be an int add, int x and y, and this will be able to throw a remote exception, and this thing is a remote. And this remote interface serves only one purpose, and this purpose is to mark something as invocable from a different machine, from a non-local machine, as they say it. Now, if we already have an interface, that's great, but we also need an implementation. So let's create the impl. And this other impl is, of course, going to implement adder, but it is also going to extend a unicast remote object. And that's because, well, it needs to be transferred there and forth into at least RMI registry. I'm gonna talk about the registry in a second. So it takes a little time. So it requires this implementation, this parent class. It allows you to have a few different interfaces, a few different constructors. We're gonna implement the simplest one, so I'm just gonna create this one, and I'm gonna call super. And add, I'm gonna say that's x plus y. Okay, and that's simple, right? Nothing complex. Now, next thing we're gonna do is we're gonna create a server, and this will be a little weird because our server will only do a very simple thing. This will be creating this adder, new input, and then doing this weird call. Now this thing is oh, and here we need also we also need to add these exceptions, which we don't care about right now. Now this line is fairly obvious. This one is I suppose much more complex. So first of all, this thing is something like a registry, so you need to define the hosts and the storage for object references to a remote registry. Now this registry can exist, and actually if you call that, it should already exist. So you should have something running on localhost 1099. Now you can run that separately, as a RMI registry, and you will have it in the JDK bundle. So you can do that. What you need to be aware of is that this registry needs to have access to all the classes that you're going to use, so all the class files. Which means that you probably have to run it in your project or set up the class path properly. And that sometimes takes a little too much work, so I'm not gonna work with that. I'm just gonna create a new registry for myself, because why not? And now I do have a new registry which has no problem with anything. And now I'm gonna create a new client. And this client is also a static void, public static void main string args, and this has an adder. It uses a stub, but we don't care about that much because details are provided by a lookup in naming registry. And the address here is RMI localhost 1099 adder. I think adder was that the name? Adder, yes. Okay. So that's what we're gonna do. And of course, this can throw an error. So we're gonna add something here. And then we're gonna check out if our function works properly. So let's add some numbers. So let's add those numbers and see what happens. So we start with running the server, as always. Oh yeah, address already in use. Which means that I forgot to stop my previous server. Let's check it out now. Yeah, now it's fine. So let's run the client now. And it works. Great. Now, as you see, that's it for the basic usage of Java RMI. So the simplest solution is this, and it's already completed, to be honest. Now, that said, there are a few things that you should know. So first of all, you cannot do async calls. So anything you do here is synchronous. So once you call, you wait until you return from the network call. That is something you usually don't want. At least nowadays, we don't like waiting for something and hanging up the whole thread. Next thing you want to worry about is state. So say our adder is stateless, but if we had something like accumulator here, which would start with 0, and then we would say that accumulator is equal to x plus x, say, and then we would return accumulator plus x plus y. Then we will get bigger numbers, and those bigger numbers are because we use a single accumulator. So here a single adder was created, and the same object is used for all the future calls. So all the future calls will be handled by this object, which means that this accumulator should be protected. So you would usually want something like synchronize ACC and then do that. Yeah, ACC is not an object, so you need to, I don't know, maybe this, something like that. Or, you know, maybe even more, maybe make this atomic integer. That would also be okay. You just need to be aware that this might be a problem. Now RMI is you can check, by the way, on which threads are your calls handled. This registry is something that routes between your application and between the client and server. So we don't really care about that much. But there are a few more things that I wanted to show you. First of all, I wanted to show you that we can actually put objects through. So let's have an object name class. Of course that's Java, so do it like that. And it has a name, and this class is public, so we move it to a separate directory. And now our adder, it will also have a name, prefix, and we're gonna have a name n, and it will also throw a remote exception. Well, there is a problem because we need to implement that, but that's not a big deal for us, right? And we're gonna say nName equals yeah, whatever. We're on a separate computer. We can change that. And we're gonna add a Mr. prefix because why not? And then we're gonna return. And by the way, this is something you can do if you're doing remote computing, but you cannot do that if your name was local, because you would modify the original name, unless that was of course your idea. But if you don't want to modify the original name, you cannot do that. In remote we can, because we will throw this thing away anyway, but we cannot do that in local. So let's go here. Server has it, okay, and then we also want to say system out print line stub add prefix. We need to create name and new name, so let's set it to James. Let's add prefix to James, and then we're gonna say name. And if we do that, we're gonna see that it doesn't actually work. And it doesn't actually work because our client is not serializable. Not client, sorry, name is not serializable, which means that name might have some data that cannot be sent by network. But if we say that it implements serializable, then all of a sudden the runtime says, okay, whatever, if you want to serialize that, that's your problem, and it works. Now, why do we need to do that? That's because some data can be sent through the network, and some data cannot be sent through the network. Now, some data that cannot be sent through the network, this includes memory references, file references, basically any references that are local, database references, this kind of stuff, which are fairly common to manage in a typical Java program. Now, if you manage them, you cannot send them through the network, so you cannot serialize them. There is one more thing you can do. So if you have a secret that you really need to keep here, so say you have a secret number, you can mark it as transient. And here, let's say we have a rogue system, rogue server, and it says, okay, I will add this Mr., but I will also print out all your secrets. So I will print out your secret number. So we can say, haha, my secret number is transient. So my secret number is 1111, and once I run that, the server prints out 0. And that's because secret number was not serialized on the network. You shouldn't be using that for providing secrets and for making it safe. And you generally should have much stronger guarantees for safety, for security things. But that's something worth knowing. And that's it when it comes to RMI. It's, as I said, a fairly simple technology, and it's, at least when it comes to usage. One last thing I want to show you is the Wireshark thing. So if we go through the network, that's something I saved earlier, so it's not our call. So if we go through the network trace, RMI is seen as a separate protocol, and you can see it here. It goes through IP, then TCP, and then RMI, and it's a binary protocol with all those thingies coming here. I mean, it's not binary, but it's not a textual protocol, so I'm gonna call it binary. So here we have some things that you technically could try to read, but are not really readable. They're meant for machine to let's say, unmangle. And this is the default Java serialization. You probably shouldn't be using it much nowadays, but if you encounter that, that's a separate thing, and you can diagnose it using Wireshark as always. So you have all those things here as well. Okay, thank you for listening. That's it for today, Java RMI exercise. Have a great day, and see you on the next one.